Hi everyone, my name is Mark. Hi everyone, my name is Mark and I'm here with the Shell STEM program which is powered by NIHERST. And today what we'll be doing is a follow-up on Newton's laws of motion. So as you recall, Newton's first law of motion states that an object at rest stays at rest and an object in motion stays in motion unless an external force acts on it. As we go to the second law of motion now, the second law states that a force is equal to its mass by its acceleration. So you're multiplying the mass and the acceleration. The unit for a force is Newton, and we get this when we multiply mass, which is in kilograms, and acceleration, which is in meters per second squared. So when we multiply them, we get kilogram per meter per second squared, which is also a Newton. Let's do a simple experiment now to see how Newton's second law of motion helps us find the force of an object. So I have this ball here. Now while this ball looks really small, it actually weighs 1.2 kg, which is kilograms, and I'll hold the ball at a certain height. Right? So let's say this height, this is above ground, and we all know that gravity is acting on this ball right now, and acceleration due to gravity is 9.81 meters per second squared, and the mass of this ball is 1.2 kilograms. So if I hold this ball here and we assume that there are no external forces acting on this ball, okay? Zero external forces, no air resistance, nothing else is acting on this ball. So as I release this ball, what we'll calculate is the force at which the ball hits the table, right? So let's listen. Now that was a pretty solid impact. Okay guys, I'm sure everyone heard that. We'll calculate the force at which the ball hits the table. We know the mass of the ball is 1.2 kg and the acceleration due to gravity is 9.81 meters per second squared. So when we multiply both of them, we get 11.8 newtons, and that is the force at which the ball hits the table. So at home, you can try this experiment with different objects. It does not have to be a ball, but whatever object you're using, make sure and weigh it first because you need to know the mass of the object, of course. We've seen how we can calculate the force of an object by knowing its mass and acceleration, but we can also change up the equation where we can calculate the mass of an object if we know its force and its acceleration, or we could calculate the acceleration of an object if we know its force and its mass. Before I go, I'll leave a question with you all where you need to calculate the force of an object. So my question is, you have a toy car at home which has a mass of 10 kilograms and you push it until it reaches a velocity of 2.5 meters per second after 5 seconds. I want you to calculate the force at which that car was pushed in order to reach that velocity. Right? So you have to calculate the force using Newton's second law of motion, but I'll leave you all with a hint. Before calculating the force, you need to find the acceleration of the car. So leave your answer in the comments below. I hope you all enjoyed this video, and remember, science every day.
Wow!
Thanks for viewing and thank you for joining our Shell STEM program powered by NIHERST. Now we'd love to get your feedback, guys, so we've attached a short survey in the description box below to get your feedback. We've also made online courses available on the Ministry of Education's website at learn.moe.gov.tt. Subscribe to our YouTube channel for more videos because they're going to be coming, and stay connected to us on our social media profiles at Instagram and Facebook at NIHERST.